Okay, guys, in this class, I just want you to understand typical questions that you might be given. That is the simplification that you might be given of your algebraic expressions. Algebraic expressions is the major important part that you're going to need in your syllabus. That is, you need the first thing to understand basic concept of your algebra. All right, that is the basic concept of our algebraic expressions. So we've got this part of our algebraic expressions. What is it that we are referring to on these algebraic expressions? We used to work with normal numbers in in the simplification. Maybe it's addition, subtraction, multiplication, division, whatever that you're having. We used to work with numbers. Maybe it's just a 2 plus 3. All right. These are just numbers that you're used to. All right. Maybe it's a 2 plus 4. Maybe it's a 2 plus 7. Whatever that you're having there. These are just normal numbers. So the algebra part is now we are having the use of letters. We are now using the letters. There is now a part that consists of letters. X, those Y, those M, those N, whatever letter that you can think of, together with the numbers. So you'll be having maybe it's 3M, maybe this is 4N, maybe this is minus X, maybe this is minus 2Y. These together, they combine to give us what we refer to as algebraic expressions. So these are not expressions, these are terms. But when we combine this and this, like minus X plus 3M. A combination of a term gives us an expression. So we now have what we call an algebraic expression. So what is, let us just consider this in the actual sense. So you said the first thing if you're to consider here, we have got a term. So a term, just an example of a term you can consider just like 2x. That's a term. So you've got a number and a variable, a number and a letter, minus 3x. These are terms, a combination of a number and a letter. So you're going to see that this is a combination of a number and a letter. Let us just remove this. So this is a combination. I'm going to have a combination of a number, and a letter, which is the letter that we are considering. Just any letter that you can talk of, that you can think of. Anything that you can think of. Talk of, maybe it can be like this. These are terms. That's a term. So a combination now that is of a term cannot be just a multiplication. As you can see, it's a multiplication there. It can also be a division like this. If I have got x over 2, it's a term. It can be maybe z over 3. It's also a term. That's a term. So the difference that we have now from a term and an expression is that an expression is now a combination of addition and subtraction of these terms. That's an expression. It's a this one, it was a combination of a number and a letter by multiplication. So it can be by multiplication or division. So it can be by multiplication or division. Whenever you see this, that is those are the terms. You're talking about a term. An expression, it's a combination, but this combination that we're having is on addition and subtraction. So that's a combination of terms now. So this one, it's a combination. We're gonna have a combination of terms. These terms that we had before, they are now combined together. So the combination now gives you an expression. So the combination can be by addition or by subtraction. This one was multiplication or division. So this one is by addition or subtraction. So it's going to be by addition or subtraction. All right, that is the idea there. Either by addition or subtraction. So that means if I have an expression, I've got something like this, 3x minus 2, 4x plus 3y. These are expressions now. A combination, we are now combining those terms that we had before. So if you are to take this together with the simplification of algebraic expressions that you're going to have or that we are going to talk about, you're going to see that it is very, very important that you understand that. And on a term, you're going to see that it is a variable that you're consisting of, which is the letter. There's a letter there, and there's a number that is affecting that letter, which is referred to as the coefficient. So this one, if you're referring to x as the coefficient of x. If I am given minus 3x, like the coefficient, the number that is just before the letter, the number that is multiplying the letter there is your coefficient. So these terms, they can be different. You can talk of a combination of different terms. You can talk of a monomial. So this one, I'm just going to talk about this in passing. A binomial. We can also have a trinomial. And we can also have a quadrinomial. All right. So these are the typical polynomials that we have. So this one, you are going to see that it is just a polynomial consisting of one term. So there we just have a single term, just maybe 2x, just a single term. That's a monomial. Monomial. Mono means one. Monomial. So that's one term. Binomial, from the word bilateral, by this, whenever there's a bi, that's a two. So bilateral, binomial, bino. Yeah, all right. So that is what we have there. We've got a binomial. So the bi there, that is two. Mono, this one. It's what? It's a one. Tri, that is three. Quad, four. So you can even take it from that way. So a binomial, it is going to be consisting of two terms. So there we are going to have two terms. For an example, you can just have this, or maybe it's 2x plus 3, just two terms. Like I said, tri means three. So a trinomial is going to have three terms. So here we are going to have a combination of three terms. For an example, that is x squared plus 2x plus 3. Just an example. Three terms, 1, 2, 3. Combination of three terms, that's a trinomial. A quadrinomial, quad, that is 4. So a quadrinomial, that is, we're going to have 4 terms. That's a quadrinomial. So you're going to have 4 terms, e.g., x to the exponent of 3 plus maybe 2x cubed plus 4x squared plus maybe, all right, 3x. Let's see, 1, 2, 3, 4. All right, something like that. All right, guys, here I have got a repetition here of the same exponent. I just want to have something like this. All right, so you've got 4 terms considered there. Just an example that you're having there. So that's a quadrinomial. So a trinomial, a binomial, you have to know each and every part that you're given, the number of terms that are there in each and every expression. So with this, we're going to talk of the simplification of which that I'm going to explain as we are moving on. With this, I think we can be able to understand each other because we shall be talking of these terms and you wonder, what is it that you're talking about there? All right. So the first part of the question that you're given, it was consider the expression. That is, we've got an expression, this one. How many terms? 1, 2, 3, 4. That's a quadrinomial. How many terms are there? That is the first question. How many terms? So you count, there's a term, there's a term, there's a term, there's a term. So that there are 4 terms there. So we've got 4 terms. What is the constant? Constant What is it that you are referring to? A constant. A constant meaning to say we do not have a letter. It's just a number that we have. There is no variable. That's a constant. So the constant in this case, the 7. Here there's x, here there's x and y, here there's y. So this one is our constant. So the constant term is a +7. Then state the coefficient of the term in x squared, y squared, in x and in y. So take note, I talked about the coefficient to say the coefficient is the number that is affecting that letter. So if you're talking about the coefficient, let's just have it here. So we are referring to the coefficients in this case. So take note. The first one is the coefficient in x squared. So in x squared, what is going to be the coefficient affecting x squared? That is where we have x squared here, x squared. So the coefficient is the number that is multiplying x squared, this one, which is what? Which is a 2. So that is the coefficient, the number that is affecting x squared. The same thing, y squared. Where are we having y squared? The coefficient there that is on y squared is, this is a y squared, this one. So the number that is affecting that y squared, this one, is -9. So that's the number that we have, that we need, which is a -9. So we have to be very, very careful. Very, very careful. So there, that is a -9. Okay. Then the coefficient of x, it means we need where there is x. So if you're to take a closer look here, there is a statement here, -8xy. -8xy. That is where x is. Not x squared, no. We need where x, not x squared. So if we are to consider x, it means we have to, this is our x, this one. This is your x. Take note, this one is your x. So what is affecting x? What is affecting x is -8 and y. That part that is remaining, the part that is remaining, this one, is the coefficient of x. The part that is remaining, that is multiplying what? Multiplying x. So because you're considering x, -8y becomes the coefficient. Even y becomes part of the coefficient when it is like that. It's not just like you're considering a number only. So when you're considering x, it follows that the coefficient of x is going to be -8y. So the coefficient there is going to be -8y. If we are considering the coefficient of y, because we need also the coefficient of y, it means this time we are only focusing with the part of y. That is our focus now. This one. What is affecting y? What is affecting y is this part that is remaining, which is the -8x. So meaning to say the coefficient of y is -8x. The coefficient, what is multiplying? What is the variable that is given there? So if you're referring to y, it means this is the coefficient. What is remaining here, multiplying y? That is the idea. So guys, you have to be very, very careful. You have to be very, very, very careful in the simplification because they are going to ask these typical questions of this nature. So you just have to be very, very careful in the simplification. In the simplification that you are given there, you have to be very, very careful. Because questions, they can differ with how you are given. Questions may just differ. All right. Let's consider the other part that we are given of the same question, which is part 4. Determine the value of the expression. This same expression if x is 2 and y is -1. So this one is just a substitution that you are going to do. So what are we simply having? This is our expression of the one that you're given. The expression that you're given is 2x squared -8xy -9y squared. So this is what we have, -9y squared plus a 7. So we are given that this moment x is 2 and y is -1. So in place of x, you're simply going to substitute what you're given for x. So this is 2 into 2 squared. Minus 8 times x, our x, which is 2, y is given as -1, minus 9 times y squared, the value of y there is -1, but it's -1 squared plus a 7. So that is what you're given there. So you have to simplify the whole of this part. So it's either just going to simplify this part here, meaning to say you're going to have 2 times 2 squared, that is 2 times 2, which is 4 times 2, which is 8. So this will be 8. A minus and a minus here, that will be a plus. 8 times 2, which is 16 times 1, that will be a positive 16 here. -1 squared, that is -1 times -1. So negative, that will be a positive 1. But there's a -9 there, so it's -9 times a 1, which is going to be -9 plus a 7. Or just use your calculator. So this is supposed to give us a 22 here. This is supposed to give us a 22. All right. Let us have this calculation once again here. Just want you to see, is just see this issue of software is this and that, guys. Yeah. Sometimes you end up filling in wrongly here. So this is a 2 squared. Minus 8 into a 2, then that's a -1 that you're having there. So you've got to have a -1, minus 9 into -1 squared. So this is -1 squared, then plus a 7. So I think I forgot this one. So that's a 22 there. Yes. So if you check, you're obtaining the same thing, which is a 22. So you can even use that to your advantage as a simplification. So this is the same thing that is happening on this part of the question that is remaining on this B. If you check the B part, if x is equal to, so on B, we are given the conditions that x is equal to -1/2, and also we are given that y is equivalent to 4. These are the determine the value of the expressions. So when you are given this now is the numerical value that you're supposed to determine. Like number 1, you're given the product of xy. So it simply means I just have to multiply. What am I having for x? That's a -1/2. xy means x times y, which is a 4. That is what it means. So -1/2 times 4, that is going to give you a -2, or you can just use your calculator. But that's this into this, that's a 2 there, which is -2. So that's the idea. So we simply have to it's a substitution that you're having. So x minus y on number 2, what does it mean? X minus y. Just going to substitute. What is the value of x? The value of x, that is a -1/2 minus the value of y, which is what? Which is -4. So if you want to simplify, yes, you can do that, guys. This is same as you can write it as over 1. Then you're gonna find LCD, which is 2. 2 divided by 2, that is a 1, times -1, which is -1, minus 2 divided by 1, that is a 2. So it's 2 divided by 1 like this, which is a 2. Then times this 4, which is 8. So this will give you a -9/2. Or just simplify. This stage, guys, just use your calculator there. You're done. As long as you've substituted properly, whatever that follows there is something else. So this is -1/2. So you're going to have this -1/2 like this, -4. So this is a minus here, this one for subtraction. You subtract a 4. So this is -9/2, just like that. So meaning to say, after the substitutions have been made, then what you need there is to simplify. You're just substituting whatever that you're given according to the question. So I want you guys to try as many questions that you're given. So if you check there on number 6, we are given something like 1 minus 3x cubed. 1 minus 3x cubed. All right. So what does this part mean? We simply have to substitute. This is equivalent to 1 minus 3 into x cubed to the exponent of 3. That's x cubed. So x is -1/2 to the exponent of 3. So this stage is just a simplification that is happening there. Just substitute your values direct as they are on your calculator. So you can even do this stage by stage. This is -1 into -1 to the exponent of 3, which is going to give us -1/8. -1 to the exponent of 3, that's -1. 2 to the exponent of 3, which is 8. Or you can just do that on your calculator direct. Okay, so this is it here. Just show stage by stage. That's -1/2. So you've got -1/2 like this to the exponent of 3. And that is gives you, it's going to give you a -1/8. So meaning to say I can simplify this whole part that is remaining -1, 1 minus 3 into -1/8 like this. So this can be simplified. That is going to give us 11/8. So you can even simplify that way. You can simplify that way. So these are the typical questions that you might be given. All right, so it's the same thing as what you can see here. Let's just try to simplify question number 7. With the same information, we are given now the square root of 2xy like this plus 5y. So remember that x is a -half and y is a 4. So this simply means this is going to be the square root of 2 times x, which is -half, times y, which is a 4, plus 5 times 5y means 5 times y, which is 5 times 4. So this is a single part. This is a single part to be considered. So meaning to say we are going to have the square root of, we can even simplify this whole part. So what are we going to have? The 2 and the 2 can cancel. -1 times 4. That is a -4. Or you can just use your calculator there. Then 5 times 4, which is going to give us 20. Then if we add -4 plus 20, that is same as 20 minus 4, which is 16. And what is the square root of 16? The square root of 16 is plus or minus 4. So this you can even simplify as it is on your calculator. As it is on your calculator. What are we having? This is a single part that we are having here. So it's going to be the square root of 2 times -1/2, -1/2 times a 4, plus, what are we going to have? 5 times 4. So this is 5 times 4, like, and this is 4. But knowing that the square root of any number is what? Plus or minus. That's the idea there. Square root of any number is plus or minus. So I want you to try as many questions on this part, even this one. Let's see where there's a challenge. Let me know so that we can work that part together. On number C, these typical questions, what exactly are you given that you need to simplify? There are terms that you can actually be able to simplify by the condition of knowing what you refer to as the like terms. The like terms, these are terms that can be added. They can be added. They can be subtracted as long as they are like terms. So when you're considering a like term, it must be of the same letter, same exponent. Same letter, same exponent. If I talk about maybe x to the exponent of 2, these are the like terms for x to the exponent of 2. The variable has to be the same and having the same exponent. If that condition is there, you can combine those like terms by adding their coefficients or subtracting their coefficients. Just like, for an example, 2x plus 3x, I just add the coefficients of those variables, which are the same. These are like terms, x and x. This is x, this is x. Same exponent to the exponent of 1 to the exponent of 1. So I can add 2 plus 3, which is going to give us what? A 5. And that x remains as it is. So you just add the numbers that are affected, this one. These are the numbers that you're simply combining. There is a minus, you're going to subtract. There is a plus, you add depending with what you're given them. So what I'm simply trying to say is that if I'm given 12xy minus 10xy, that's like, because this is xy, this is xy. So you can subtract 12 minus 2, minus 10, which is a 2, then we're going to have xy. As long this is the same throughout. That is the idea then. So if I'm given also, even they can be raised to the exponent of 3 to the exponent of 4, x to the exponent of 4 plus 5x to the exponent of 4. They are like terms because they have x, we have got x and same exponent of 4. So this is same, like there is a 1. So you add the coefficients, the number, this is 1, this is a 5. So we add those 1 plus 5, which is 6. These two, which are the same, they remain as they are. It just remains as it is in actual sense. So these are the typical questions. They are testing you here to simplify this part. So given like what we have on question number 1 on C, you're given to simplify m to the exponent of 3 plus 3m to the exponent of 3 plus 4m to the exponent of 2. So in order for us to simplify, we must have like terms like what we are given to the exponent of 3 to the exponent of 3. This is from the same m. This is m, this is m. But these are not the same as m to the exponent of 2. So these are not like terms when it is referred to the exponent of 2. So these are the only like terms that you're going to consider the same. So what am I going to do on this part? I'm going to add the coefficients. What is the number that is there? There's a 1. So meaning to say the coefficient is the one that I'm considering that is affecting this m. So meaning to say I'm going to add 2 plus 3. Sorry, the 1 there that is affecting our m. So meaning to say I'm going to add 1 plus this 3, 1 plus 3, which is what? Which is a 4. M to the exponent of 3 plus 4m to the exponent of 2. So these cannot be added. They are no longer like terms because of different exponents. We shall talk about the part called factorization in another class. How do we factorize when these two cannot be added, but they are common terms that can be factored out? But in this case, it's a simplification. So this cannot be simplified. It's done. Okay. Number 2, you are given 4m squared n minus 7m n squared. So the question is, can this be simplified? Are we able to simplify this? No. No. This is different. This is m squared. This is m. This is n squared. This is m. So in terms of simplification, there's nothing that we can do there. There's nothing in terms of simplification. We do not have anything that can be added or subtracted. If it was a factorization, therefore you're going to factor, all right, m is common, so I'm going to factor out mn, then I divide, this will be 4m, then this will, the n will cancel with this, so you're going to have minus 7, m and m cancels, n squared and n, so this will be like this. In factorization, but not addition. In addition, there's nothing. It cannot be subtracted. These are not like terms. Terms that we can simplify are terms like number 4, where we are given something like this. Same exponent, same x, same exponent. So minus 8 minus 2 is what? It's minus 10. X to the exponent of 3. This one can be simplified. It can be simplified. All right. But there are other questions, the way we can see that simplification is not possible, like in terms of addition. But somehow we are given a condition, remember from our laws of exponents also, that if you are given an exponent, x to the exponent of a to the exponent of b, it is the same as x to the exponent of ab. An exponent can be multiplied together. Also, remember that if they are of the bases that are the same, x to the exponent of a when multiplied to x to the exponent, this is different from this. They are multiplying the bases which are the same. You add the exponents. You're multiplying the bases that are the same. You add the exponents together. A plus b under the same x that you had. X has not changed. you see that this is going to be used in other simplify, where you'll be wondering, what exactly am I simplifying? Like on number 3, what exactly are you simplifying? Given that I'm given m squared n 7m n squared, this is a product now, 3m squared. So that's our number 3. What exactly are we simplifying? If we are to expand here by multiplication, we're going to multiply the numbers together. That is 1 times 7 times 3. The numbers will be multiplied together. 1 multiplies 7 multiplies 3. The numbers together. So 1 times 7, that is a 7. 7 times 3, which is 21. Then the part of m is affected on its own. So there is m here, m squared. There is an m. There is also m squared. There. This is a multiplication. So if you're multiplying this, multiply to this, multiply to this, what do? You add the exponents. So it's going to be m squared plus a 1 plus the exponent of m squared, which is 2. The same thing on n. This is n to the exponent of a 1. This is n to the So this part of n is multiplying each other. So we are going to have n to the exponent of 1 plus a 2. So the part of m we multiplied. We are multiplying m and m and m. But there is m squared, m to the exponent of 1, m squared. So you add the exponents. The bases are the same. So this will be 2 plus 1 plus 2, which is a 5. N to the exponent of 1 plus 2, which is 3. So this is what you're going to have at the end. So it also tells us the exponents of our grade 10, of our grade 8, is also playing a role. Those laws of exponents in our grade 8. So I want us to try as many questions on this part. Where there's a challenge, let me know so that we can deal with those questions separately. But that's the simplification that you're going to have. So let's check number 8. Number 8, we are given that is 2x to the exponent of 7 to the exponent of 2 times x to the exponent of 2 to the exponent of 7. So with the same situation, just like what we had, but this time we have to consider that there is a number, this part, there are 2 terms there. So everything has to be raised to the exponent of 2. 2 has to be raised to the exponent of 2. So it's going to be 2 to the exponent of 2, x to the exponent of 7 to the exponent of 2, times this one is just x to the exponent of 2 to the exponent of 7. So what I just wanted you to see is that here, this 2 is raised also to the exponent of 2. So that's 2 times 2, which is 4. Remember what I said, an exponent and exponent, you multiply them together. So this will be 7 times 2, which is a 14 times x to the exponent again. Exponent of exponent, you multiply 2 times 7, which is 14. But now you're multiplying the bases, which are the same. There it's about the bases. So whenever you refer to the bases, I say this, x to the exponent of a times x to the exponent of d, you obtain x to the exponent of a plus b. You add the exponents because you're multiplying this time, the bases which are the same. So what does it mean? It means that we are going to have 4x to the exponent of, we add the exponents. That's 14 plus 14. So this will be 4x to the exponent. 14 plus 14, that's going to give you a 28. So that's it. So the simplification, it's how. How is it given? That's the simplification. How is it given? So I want you to try as many questions. All right. The other part of simplification that we can see is the part D. The part D that we are given is again to simplify. Number 1, we're given minus into m squared minus 3mn. So you wonder, what is it that you're supposed to simplify? Whenever you're given the brackets, you need to expand what is outside of the bracket. The term affecting the bracket here, there's a negative, which means there's a negative one. So it's negative times m squared which is negative m squared, negative and positive. Negative times negative, you distribute the negative inside. So negative, negative, that's a positive. So that will be positive 3mn. That's the idea. So the simplification is, how are you given the questions? Are you talking of expansion of brackets? Given two brackets, given a term outside of the bracket, like what we have on number 2, this is 3 into a minus b, minus 2 into 2a minus b. So you have to consider what is outside of the bracket, the term, the number that is affecting the bracket. What is it? It is the one that is you're going to distribute throughout. So here we're going to distribute by 3 here, going to distribute by 3 here. So what are you going to have at the end? 3 times a, that is 3a. 3 times minus b, this is the same as minus 1b. So it's 3 times minus 1, which is minus 3b. The same thing with the minus 2, the sign plays a role. It's also a minus there affecting a plus 2. So it's minus and a plus, which is a minus. So that will be minus 4a. Minus 2 times plus 2, that's minus 4. Again, minus 2 to the minus b. So that is going to be minus times a minus, which is a positive 2b. That's the idea. What is affecting the bracket? Each bracket, there's a term, there's a number there that will affect that bracket. So from there, after expanding the brackets, do you have the like terms? Are you having the like terms? You consider now the like terms. So the part there, we've got 3a and 4a. These are like terms. So this is same as 3a minus 4a. We've got minus 3b and 2b. So you can even start by a positive plus 2b minus 3b. So let's subtract 3 minus 4. 3 minus 4, that's minus 1. So it's minus a. Minus 1a is same as minus a. All right. The same thing, 2 minus 3, that is going to be minus 1b, which is minus b. So that's it. So you have to be very, very careful how the questions are given in terms of your simplification. Consider what we have on question number 3. I'm not going to write everything. I want you to try as many questions there. Where there's a challenge, let me know. You're given minus into x squared minus 5x minus 6 into minus 2x, like this. So if you are to consider, there is this trinomial that you're given inside this bracket, and you've got a monomial there. So guys, this can just multiply the negative here, that's a positive. They can multiply each other, negative, negative. Just like this, minus 1 times this, minus 2x. So that can give us a positive 2x into the bracket of x squared minus 5x minus 6. We are done with this. We're done with this. We've multiplied this. It's now a positive 2x. So now that means we can expand the brackets by 2x. So 2x is going to be, we are going to distribute everything inside by 2x. Everything. 2x times x, this to the exponent of 1. So that will be 2x to the exponent of 1 plus 2, which is a 3. 2x and minus 5, that will be minus 10. X to, and x here, so that will be 1 plus a 1, which is what? Which is a 2. 2x and minus 6. So if you multiply 2 times minus 6, that will be minus 12. So that's going to be just minus 12x. Just minus 12x. Just minus 12x. So guys, you have to be very careful how the questions are given. The simplification part is very, very important later on. How do you simplify these questions and so forth? And never be tempted like what you have on question number 6. Like I said, I want you to try as many questions, but let me just end with you. On number 6, where you are given this one, you could have been tempted. This is 2p minus 4 into 2p squared minus 1. Never be tempted on this question, because what is affecting the bracket there? It is this term, this one. Please be careful, this one, minus 4. The number that is in contact, the number that is in contact with the bracket, that is the -4, not the 2p. The 2p is not there. Unless if they could, unless it was like this in brackets like this. What is in contact, it's a bracket, so you consider everything now. But there is not like that. No, it's like this. So it means what affects this bracket is not 2. No, it is not that. It is -4, the one that is in contact with the bracket. So meaning to say this was going to be 2p, the -4 distributed throughout. You distribute this by -4. So that's -4 times times a positive. This one is a positive, so it will be -8 p squared. -4 and -1. Minus, that's a +4. We'll just use a calculator there. So at this stage, you're done. You can just maybe rewrite this as -8 p squared plus 2p plus 4. Just leave it like that. You're done. There are no like terms there. There's nothing that can be added or subtracted. So sometimes it can be that they're like terms. All right, this one, guys, I took it as -4, but it's supposed to be -4p. All right, so this one I actually did a question of my own. So let me have the question, the actual question there. Actual question is what? -4p. There is a p. And never be tempted to subtract to say 2p minus. No. Never be tempted. All right. So this one was going to give us -2p, then -4p and 2p squared. So minus and positive, that will be -8p. This is to the exponent of 1. So 1 plus a 2, that will be a 3. So it's like there's only 1p here. Here there are 2 p's. So if you combine with 1p, how many p's do we have? There are now 3. All right. -4p to -1. So it's minus to minus, which is going to be a positive. 4p times, so it's going to be positive 4p. Negative cancels. So this is what you're going to have. But now after expanding, you can see that there are like terms to be considered on our expression. This part of p, this part of p, these are like terms. So you can add these two terms together. 2p plus 4p, which is going to give us 6p minus 8p cubed. That's it. So you have a lot of questions on this exercise to work on. Let's try as many questions where you figure out, okay, here I'm having a challenge. Let's discuss on the comment section so that we can be able to revise those questions in our next class. So make sure that you understand each and every part that you're given, because these are going to be your typical questions in your final exam. They are going to have similar questions like these, or similar questions. Be careful. Be very, very careful how your questions are given. So let's try as many questions as we can. Where there are challenges, let's communicate in the comment section. But for now, that's it till we meet again.